Question 23 wants us to use the quadratic formula to solve. So in order for us to use the quadratic formula, number one, this has to be a quadratic equation. Highest power is a 2, which is a quadratic. The next thing is that you cannot have a number other than a 1 in front of your squared term. So that is good too. And your problem needs to be written in the right order, in descending order, set equal to 0 in order for us to solve, which is in standard form. Our problem is in order. There are no missing pieces, so we can identify the numerical coefficients of each of these terms. So the numerical coefficient, the number in front of your variable for your lead term, is a 1. For the middle term, it's a -4. Be careful with your signs here. If there's a minus there, you have to include that. And your constant here at the end is a -8. So the quadratic formula is included on the hints page. You can use that for your final. It's minus b plus or minus the square root of b squared minus 4ac all over 2a. So I'm going to rewrite this problem with parentheses around the place where I am going to be plugging in numbers in the place of these letters. Okay, so I'm plugging in a -4 in the place of b, and notice that with the parentheses, this helps me to recognize that the minus sign out here in the front is not the minus sign on my negative number. A lot of people make that mistake. A is 1 and C is a -8. The term that you identified for B will always come out with the opposite sign because of this double negative property. Negative on the outside of a set of parentheses and a negative inside is going to change this to one big positive number. So this comes out as a +4. -4, the quantity of -4 squared gives us a +16. And if you need to think about that off to the side, -4 times -4, negative times a negative makes that positive. That's why this is a +16. Okay. Then we have -4 times 1 times -8. A negative times a negative here makes it a positive. So we have a +32 there. And 2 times 1 is just 2. So we have 4 plus or minus the square root of 16 plus 32 is 48 over 2. Now, can we simplify the square root of 48? Let's break that down. Well, we know 16 times 3 is 48. 16 breaks down to 4 times 4 times 3. Our index here is a 2. It tells us we're looking for things in sets of 2. And for every set that we get, one of these numbers comes out to represent this set. This one does not have another 3, so that 3 has to stay inside. So this simplifies to 4 square roots of 3. So right here, I can rewrite this as 4 plus or minus 4 square roots of 3 all over 2. Now the question is, can we reduce this? When you look at this problem, if your denominator can divide or simplify with each one of these terms, then yes, you can reduce this. It has to go into both of them though. It can't just go into one. 2 goes into 4 2 times. 2 goes into 4 2 times. Okay. So this is my final answer. Now Pearson might want you to write this separately, so I would have 2 plus 2 square roots of 3, comma 2 minus 2 square roots of 3. And that would be my final answer.